Right. Uh, Continuing the previous video, we'll talk about the ground unification theory, so-called the GUT. So in the previous video, we discussed two things, both of the S5's representation for the barometer field, that's 5 bar and 10. And also we consider the 25 representation for the Higgs, and there will be the 24 generators, including the B boson, W boson, gluon, and XY boson. And that XY bosons representations of the S3 and S2 simultaneously, and we saw that the gauge interactions related with the XY, which can impact on the baryon number violation process, like as a proton decay. So, right. In the remaining part, I will talk about the Yukawa interactions for the barometer mass, the burst, and the second, I will talk about the arch learning for the gauge coupling. So the gauge coupling is a unit byte at the higher scale, and finally, I will talk about the non-minimal GT, like as SO10 and SUSY GT. So the Yukawa interactions in the GTs are given like that. Higgs is the 25 representation of the Higgs cannot couple to the fermion. So the 5 representations of the Higgs participates Yukawa interactions. Here's the psi is the 5 bar and the chi is 10 representations here. So there are two types of Yukawa interactions possible, like as one psi and the one chi and the two psi. And the fermion mass is proportional to the Yukawa coupling, and the babs of the Bab representation Higgs, and there will be the fermion mass light years. But that predictions the fail, so that there should be the more complicated Higgs structures recalled, like the body Bab representations. I'll skip the details of such a complete structures of Higgs. Now we'll talk about the gauge coupling learning. The beta functions of the gauge coupling has a following typical form, where the T is the ln mu with the n scale mu, and there will be the beta function coefficient pi with the I equal 1 to 3, which correspond to the u1, su2, su3 respectively. And for the standard model, if we calculate the order one loop with the fermion field and Higgs field, then the U1's abelian gauge coupling is the positive, but the non-abelian case the beta function coefficients is negative. And if we set the alpha with the dimensionless coupling, then the also the difference with the standard model coupling, we should use the G1 as a GT normalization, so just G primes that for the electroweak the couplings for the U1, so the Weinberg angles is given by the ratios of that. But we use the G1s with the additional root of the 5 of the 3 factors. Then the beta function for the alpha I can be calculated by using the derivatives rule. Then that is just given by such a form. And if we consider the inverse of the alpha, then there's no dependence in the right hand side, so that is just the constant behaviors. So the slopes of the alpha is given by just the constant over the energy scale. So the 1 over the alpha so appears like that, depending on sort of the positives or negatives coefficients of the beta functions. So if we learn the gauge coupling from the electroweak scale, W boson mass, to the some specific higher scale, then that is given by the log function, because the T is given by the LMUC here. So if we insert such a beta function coefficients of the standard model, then we can obtain this such a plot from the starting of the electroweak scale with the 10 to the 2 gigaelectron volt. The couplings, inverse loops coupling for the U1, SD2, SD3 is almost missed around the 10 to the 16 CV, but they do not miss exactly in the standard model. But if we consider SUSY particle, which is inserted in the 10 TeV scale, then after this 10 TeV, the beta function coefficients that changes because SUSY particles are contributed in the one loops, and it makes the difference loop with the kinks in here, so that we can make the such a three different coupling mystery the around the 10 to the 16 CV as a grand unification coupling. There are some peer remark. The SU5's GUT symmetries are broken to standard models by the spontaneous symmetry breaking. And if we consider second homotopy groups for this degenerate vacuum, then it can be classified topologically. Then the homotopy groups of the given degenerate vacuums given by the chart. So this makes the GT monopole, but in the cosmologically there's no monopoles in the universe, so it makes a monopole problem. And there are still the problem in the GT, like as this hierarchy problem, the Bab sort of 25 representation of the Higgs and the Bab for the 5 representation of the Higgs has a very big difference, because this makes the GT spontaneous symmetry breaking, but this Higgs gives the electroweak symmetry breaking. And also inside of these 5 representations, the colored Higgs, the 3-part and the 2-part, has also the different mass. This is a correspond to the standard model Higgs, but such a colored Higgs should be the very large mass, so it makes a doublet and the triplet splitting problem. And such a grand unification can help to explain the baryon symmetry of the universe. So there are GUT baryogenesis model. Such a GUT is include the B-bar relations. Already standard model includes the B-bar relations, and also in the color Higgs there will be the additional CP-bar lighting phase is possible, so they can satisfy the Sakharov conditions. In the remaining time, I will talk about the beyond the minimal's SU5 GUT, so non-minimal GUT. The first possible is SO10 GUT instead of SU5. In the SO10, the fermions has such a 16 representations, so among the 16 degrees of freedom, the 10s correspond to the 10 representation fermions of the SU5, the number of the 5 bar, and there will be addition of the 1 representation which corresponds to the right-handed neutrino. So the right-handed neutrinos is a naturally inserted in the SO10. And in the SO10, the number of the generators are given by the n times n minus 1 over 2. So there will be the 45 gate bosons in here. And among the 45 degrees freedom, the 24s correspond to the SU5 gate boson, and there will be the additional 10 and the 10 bar representations and the single lot. And for the Higgs, for the 1 index, that's just given by the 10 representation, but if there is 3 index, then there will be the 120, and they can decompose like the direct products of each representations. And there will be the 5 index. Also, we can calculate the degree of freedom with the combinatorics, and they can be decomposed with the direct products of the representations. And especially this 126 representation, there will be the singular representations, which is the correspond to the right-hand neutrino, which can provide the neutrino mass naturally. Also, the interesting characteristics of the SO10 is the breaking chain from the SO10 to the standard model. We already noticed that each group, so this SO10 can be the break to the such a C5 one, which is the 5 one means that there will be the SU5s and times as U1s, and it can be broken to the SU5, which is to correspond to the minimal GT, and if eventually it arrives as a standard model gauge symmetry. But there's also the other way. The SO10 groups can be broken to the SU4 color symmetry times the left-right standard model, the so-called G422. And there are several chains like the SU4 colors times SU2 times 1 and SU3 colors and SU2 left-handed, SU2 right-handed, and the U1. And it arrives at such a G3211 and eventually is equal to the standard model's symmetry. The other way is to the minimalist duty is the SUSY duty. Now all the fields are written by the Schiffer fields. For example, the color Schiffer fields, there will be the psi as a 5-bar representation and the T as a 10 representations, and they are shaped the 2 Higgs doublet, not to break the supersymmetry. So they are shaped the 2 Higgs and the 2 kinds of the color interactions. And there will be the pi as a 24 representation to make the CC broken. And by using such a color Schiffer field, we can construct sort of the Schiffer potentials, like as the Euclid interaction term form with the 10 representation term presentation on the Higgs and the 10 and the 5 bar on the Higgs. And the interesting characteristic of the SUSY GT is that there will be some Gaussian numbers integration, so the dimensional analysis is different. So the baryon number variations is a high dimension of flight surface and dimension of 5. So there will be the 2 corks in here. So the dimensions given by the m of the 3, and there are 1 corks and 1 leptons. This dimension is 2. So this dimension of this higher flight is given by dimension 5. So the subfraction is relatively small. And in this case, the dominant decay channels of protons are different, like as the count and the neutrino. So this is the very sort of the GT. So we talk about the several things, sort of the SF5 representations and the interaction, gauge interaction, co-interaction, and the paranormal variations, so the proton decay, and the gauge coupling unifications with the arch learning, and the non-minimalist GT.